Real-World Computer Programming for Kids, Step 35, Introduction to Databases. We just finished the first major leg in our journey, traveling through the sometimes bumpy Windows Forms land. We will now continue our scintillating journey by heading towards Databaseville. We will be using what we just learned, though. In fact, a little bit later, we will create another Windows Forms app to display the data that we're going to be creating and working with. In that project, we will continue to use C# as the programming language, and of course, we will still be using Visual Studio as the IDE, or Integrated Development Environment. So, what will be new? All of the database-specific stuff, which we will start this next project with. This includes a new programming language. Similar to the case with JavaScript as opposed to Java, not all people consider Sql to be a true programming language. But in my mind, their arguments are hair-splitting ones, and I will speak of Sql as a true, valid programming language, as I will of JavaScript later when we get to it in the next major leg of our journey on web technologies. Note, the acronym SQL, spelled that way, is sometimes pronounced with the letters spelled out, SQL, but more often it is a homophone of the word spelled SEQUEL, and thus it is pronounced as such. So you might say, I'm going to watch the sequel to Waylon and Willie Meet Godzilla. And you also might say, I am going to write some SQL to query my database for how many movies there are about Waylon and Willie. For those who don't know who Waylon and Willie are, think of an outlaw country version of Bill and Ted. So what is SQL? It stands for Structured Query Language. So, it's a language, a computer language. It's structured, of course, what else? But the most interesting is the query part of the name or acronym. A query is what? The same thing as that was, what I just wrote, a question. So using SQL, you are asking questions using a structured language. Of whom are you asking the questions? The database. Why? The database is full of data. But it may be so large and scattered across so many tables that it is hard to make sense of it by just looking through the tables without querying it, asking for specific data. As in all programming languages, you must ask the database the question in exactly the right way for the database to understand it and return any results. That is the data that you want that answers your question. Let's compare this machine/computer language or hybrid machine-computer language to human speech. When humans interact with each other, they can ask the same question in several ways and still be understood. For example, to ask for the weather prophecy or prediction or forecast, one could say any of the following. What's the weather going to be today? What's the weather going to be like today? What's the weather today? How's the weather looking for today? What does the weatherman say? How hot is it going to be today? Or even, am I going to need my umbrella today? Or coat or galoshes or whatever. All of these things are understood by humans, most of them being virtually identical. But in programming languages such as C#, SQL, and all the others, only one very specific way of expressing things is accepted. Otherwise, the love letter that you write to the compiler, your code that is, would be considered a syntax error, and the database would refuse to give you even a clue about today's weather. Here is one more example specific to databases. If you wanted to get information from a database, but you knew nothing about SQL, you might go to the resident database expert, whether he be a programmer or even a database administrator. More on this cat later. and say to him, "Say, Fred, can you get me a list of all of our customers who live in Missouri?" And the reason I call the database administrator a cat, it's usually a cat, not a... Is it okay to say chick? Those two words usually go together, cats and chicks. And then the newsletter shows a picture of cats and chicks. The dude would know what you meant and write SQL like the following to obtain the information you so earnestly desire. Select star from customers where state equals MO. That would retrieve all the records from a table named customers, which has a column named state, which stores values in 2-character abbreviations, such as MO for Missouri. Whereas humans can make up for sloppiness in speech and understand a variety of ways of asking a question, computers won't do that. You must talk to them in very specific terms. Any change in the above statement would be seen by the database as incomprehensible. Let's regress a little now to go back to the very basics and take it from there. What is a database? A database is a system that allows you to store information in a structured way. Hence, SQL, structured query language, is the appropriate lingo to use in communicating with it. A database includes, among other things, the following: tables, triggers, stored procedures. Of those, we will now concentrate on tables. Tables contain columns. Each set of columns comprises a row. To picture this in your mind, look at a spreadsheet that contains data. It will have columns labeled alphabetically, running from left to right across the top of the grid. So they're labeled A, B, C, up to Z, and then if necessary, start again at AA, AB, AC, etc. Below that, starting at the far left, are rows labeled numerically, numbered down 1, 2, 3, etc., up to whatever the last row is. Here's an example of a spreadsheet with a few columns, and just showing the first 10 rows of actual data, and then that is shown in the newsletter. A spreadsheet I found on the internet, in which I give attribution to. In this case, the data doesn't actually begin until row 3. Row 1 is a logo, and row 2 contains the names of the columns. This is basically the view of what a very simple table in a database contains. As you can see in that example above, a set of columns make up a row, both in a spreadsheet and in a database table. To sum that part up in a rudimentary way, we can say that a database is made up of tables, and tables are made up of rows of data, and the rows are made up of columns. But what are columns exactly? A column is a discrete and potentially discrete or restricted bit of data. So that sentence again, a column is a discrete, discrete, and potentially discrete, discreet, or restricted bit of data. Columns in turn comprise a name and a data type, like a variable in C# or just about any other programming language, and possibly some other metadata about them, such as a length value and whether they are considered the IDO value or the primary key, but discussion of such is postponed for now. By the way, metadata is data about data. So from a historical perspective, or hierarchical perspective rather, you can imagine the structure of a database as follows. And then it shows sort of a chart with database. Below that, a number of tables. Below table 1, there's a number of rows. Below row 1, there's a number of columns. And below the first column are name, data type, and other characteristics. That's a rather simplistic view of it, but it's a helpful way to start off. It's a very good place to start. The next main point for this step is, why are databases useful? That needs to be asked and answered, because some might wonder why they can't just store all of their data on spreadsheets and look it up there when they want information. If your information is straightforward and relatively small in size, that's okay. You can do that. But once your data grows large and or complex, it will help you a lot to store it in a database, and can also save space and prevent redundancy in that way. A word or two or so about redundancy. You may recall we previously spoke about the DRY, or dry programming principle. DRY stands for don't repeat yourself. In regular programming terms, this means that once you have written something, there's no reason to do it again. And there are very good reasons against doing so. That is to say, once you've got code in one place, don't repeat it in another place if you can help it. Just retain the one block of code and call it from as many places as you need to. Specifically for databases, though, what we're thinking about when we use the DRY acronym is DRY. Don't store values more than once, or don't store a value more than once. For example, a customer's address. Why store 157 Riverside Avenue, Champaign, Illinois, 61821 over and over again throughout your database, such as for every order the customer at this address places? For one thing, it saves space to only store the address once. For another thing, it prevents multiple unique versions of what is really the same address. What I mean by multiple unique versions of what is really the same address is this. If you were to store the address anew each time the customer placed an order, you could end up with the following in your database. And then it shows several different versions of that same address that are slightly different, maybe abbreviating avenue with AVE, abbreviating the name of the state with IL, which is really the standard way to do it. And so they're all slightly different from each other, but they mean the same thing. And the software you use to send out mailings may see all of these as distinct and send out the same notice or advertisement to an address umpteen times, costing you extra money in postage and shipping and handling expenses, and quite possibly irritating the customer, who is perhaps now an ex-customer. And for yet another thing, you don't want to store values such as a full address in a single column anyway. Typically, each element should be stored in its own column. An address table might contain the following columns: street address 1, street address 2, city, state, and postal code, or zip code if you're just dealing with the U.S. Notice that I alluded to having a separate address table. In other words, rather than having one humongous table that contains everything and whose columns stretch off to the right into infinity and beyond, it's more efficient to break your data up into multiple tables. And as for what is probably the main reason for using a database to store your information in, is the fact that you can query it for exactly the data you need, such as all the customers in Missouri, or all the states with more than 10 million residents, or all the teams that have won multiple Super Bowls, or what have you. That being the case, that we want to use a database to store our data rather than in a file cabinet or in text files or even spreadsheet files in most cases, what we need to know is how to use SQL to get the data we want from the database. We will explore SQL as we take our next step in our journey, or next steps in our journey, starting with basic SQL in the next step. Until then,